based on the service model. Okay, so this is what we have discussed. Correct. So based on deployment, we have private, public, and hybrid. These all the are dependent on deployment model. And for service model, infrastructure as a service, platform as a service, and software as a service. We have discussed each and everything with respect to the example in our previous sessions. If you have any doubt regarding any thing, then you can just go back to the recorded sessions and listen to them. Okay. So now when it comes to the big data, firstly, evolution of Spark we have seen. So firstly, we have discussed what is Hadoop and the architecture of Hadoop we have discussed. So each and everything inside the Hadoop architecture, HDFS, MapReduce, and YARN. So we have discussed all of them, right? If you remember or not, yesterday's session, we have seen like no, we have not seen it practically, but what we have discussed how to load the data from HDFS to our DBFS. We have seen that particular thing. But the thing why we didn't do it practically means in order to do that, we need to have a Hadoop. We need to install Hadoop and we need to place some files inside that one, and then we need to map that particular things from Hadoop to this one. And it is not required for you. So that's why we skipped that part, right? Okay. So after this particular thing, Hadoop architecture, what we have discussed the drawbacks of Hadoop architecture. It is bit complex and is based on Java language. See, uh, if I say that it is comfortable only in Java, it doesn't mean that the other the other languages couldn't be integrated. It is not the thing. I worked on Hadoop at that moment based on Java. Microsoft has created a language based on Java, which is similar to SQL. That is Cosmos scripting. So it is useful to write the queries in Hadoop and load the data and then map the data, everything. Whatever we are doing in Spark, in Hadoop also, we used to do it in Hadoop. Okay. We used to do it with that Cosmos scripting language. Okay. So that is the thing. And see, that particular Cosmos scripting is not available in Google. Means when you type Cosmos scripting and all, it will not. I mean, it will not give you much information about that one because it is very very legacy projects of Microsoft only have that particular one, and Microsoft has created it and used it for its own purpose. But they haven't mm, disclosed this particular language throughout the world. Okay, so that is what it is. And see here, we have Hadoop architecture. In this Hadoop architecture, MapReduce is a computing engine, and we have replaced the MapReduce of Hadoop architecture with the Spark inside the Spark architecture. And inside the Spark architecture, if we use a HDFS and YARN, it is a standalone one. If we are not using these two, if we are using any other in Spark, then those are different. So we have discussed all of them, right? And in Spark, we have various languages like Scala, R, SQL, Java, and Python. So these are all we have discussed when it comes to languages of Spark, correct? So this is the Hadoop and this is the Spark architecture. So both of them. So HDFS, MapReduce is in Spark and YARN. Okay. Here, when you see compute engine is still the Spark and storage, it can be local, it can be HDFS, it can be Amazon S3. He's here they have taken. We are using in Azure storage account for storage, right? So we have taken all these three and resource managers come to Yarn, Kubernetes, and all. So this is how the Spark is working on. Okay. So the thing here you need to understand is when we create a cluster, all the things which are required means be it see we have four languages in the Databricks community version which we are working on. So for each and every language you are choosing, it when you create a cluster, it will always have the required means see when it comes to one moment. When I create a cluster, na, it will ask me what version of Spark you want and all, right? So see here, if I create on click create complete, see here runtime is 12.2 LTS. This is the Scala version and this is the Spark version. Okay, so not only this one, when you go to the compute section, when you click on this particular one, you could see JDBC and ODBC, what are all there here. You could see it them. Okay, and also one more thing. We have one library, which is PY4J, means Python for Java and vice versa, Java for Python. It can be used when you work on this Java. Means when you write a code in Python, Scala is based on Java actually. So it will convert the code accordingly. Okay. So this is the Spark versions. This is the Spark config. Remember when you download the Python in your local environment, means in when you download from Google and when you want to set up the Python, you will also set up the environment variables for Python. Be it Python or Java, you will be able to, you are required to set up the environment variables. So see, here also it is doing the same thing. Okay. So it is all the thing, but the thing what is differing here is the things which you are doing locally on your own and setting up all the things is on premises one, means which is with respect to your own system only you are doing it. But when it comes to cloud, it is for everyone who has subscription to this one. So that is the one thing. And okay, so we have discussed the differences between both of them and the advantages of Spark also we have discussed. And so we also discussed that it is having the stream processing. Means we have two things. One is batch processing and other one is stream processing. So in batch processing, the data will come at a certain time period interval, means for 1 hour if we are discussing, for every 1 hour the complete data will come in one batch and next hour will come in one batch. So that is batch processing. But when it comes to stream processing, each and every second whatever the data is there, it will come like it is a data flow we should say. Okay, so that is the difference between batch processing and stream processing. Okay, basically we will be in real time, we will be discussing both the batch. See, whatever the data frames you have created and whatever the data sets we have in Databricks, we are using them, right? Means that is batch processing. When it comes to stream processing, each and every second we need to take the data, read the data, transform the data, and do the things. So that is again a different process. For now, just think that you are learning the things for batch processing point of view. Okay, means there is already a data at some point, like be it a storage account or your DBFS one, data will always reside somewhere and you are taking it and you are doing the things what are required to do, means transforming, extracting, transforming and loading. So this is what we have seen till now. Okay. So going further, we will be seeing what is the stream processing and all also. Okay. So this is what with respect to Spark. And in Spark, we have three particular operations. That is uh, um, transformations, actions, and persistence. When it comes to persistence, what it will do, it is about the caching the data. So it will keep the data which is required mostly. Means the for example, if you are utilizing the particular partition of data for each and every task, then that will be residing in cache. Every time you want the data, you no need to go to memory. So it will help us to improve the time computation, and also the while you use the data from cache, it is fast and it is very what we can say is it is very easy to take the data kind of thing. Okay, so that is what, and we have discussed about these are the differences between Hadoop and Spark. So we have discussed all of them, and RDD operations. So what is RDD? RDD means re, uh, resilient distributed data set. Okay, so this is what RDD means. RDD is a fundamental unit of Spark. Okay, remember this particular point. Means whatever for whatever you have learned till now, be it speed or velocity, how you measure it, what is the fundamental unit of them, is you have discussed. But when it comes to Spark, RDD is a fundamental one, fundamental unit, you could say. Okay, so here you have transformations, actions, and persistence. So out of all these, transformations are very lazy in nature, and actions are the one which will give us the data, which will execute the things. Okay, and we have also discussed the architecture of Spark. When it is executing a job, we have discussed, right, how the Spark job is getting executed. So let me go to that particular point and show you. Yeah. So see, this is the RDD, and this is not the Spark architecture. This is just a RDD operations one. So in RDD is immutable one. We have discussed it. It means that whenever you apply any function on RDD, in return you will get a new RDD. It will not alter the one which is already residing. Correct. And not only RDD, even the data frame also, you cannot alter it. You can still create a new data frame out of it. Okay, that is what we have discussed till now. And and there is a Spark architecture. Yeah. So Spark job execution. See, definitely, they will ask you what is the architecture of Spark and Spark job execution. Means at a fresher level, they will definitely try to understand how much you know about this Spark job execution and also the Spark architecture. You already know the Spark architecture. We have seen the differences between Hadoop and Spark architecture. By that, we have learned the Spark architecture. And the most important thing from interview point of view is Spark job execution. So the Spark job execution, whenever you write a program, see, this is a driver program we have told, correct? So whenever you write a program, what it will do, it will first there will be a cluster manager. What it will do, this manager will divide the if we say there is a 50 MB of data, then what it will do, based on what cluster you are using, means what cluster you are using, how many cores you have, and how much memory you have that particular cluster. And also apart from this particular program you are running, if you are running any other half of the memory will go to that one, right? Maybe half or more than half or whatever it is. How much it is required, it will take. And with the remaining amount of memory and the course which is having, we will be running this job, right? So this manager will particularly track this all these points, like how much memory we have, and how much amount of data we are dealing with. Everything it will track. And what it will do, it will create stages based on the requirement. Means how many it is required, it will create those many stages. And in each stage, you will have number of tasks. Okay. So inside the stage, there is a executor. Executor will execute each and every task inside this stage. You can say this as a stage or it is a worker mode. Okay. So this is how it will run. And see, these all things will happen only when there is a action operation. If there is a transformation operation, what it will do, it will create a DAG. DAG means this particular one. For each job, how many stages can be created, and inside each stage, how many tasks can be created. All this evolution of the particular job will first be learned from the DAG. Whenever the action has been triggered, then it will analyze this particular DAG and apply the same things, like what after what it should execute each and everything. It will be checking. Okay. So this is the Spark job execution. And see, DAG and executor, worker node, cluster manager, driver program. These are all the terms which you need to understand. And when someone asks you technically, what do you know about executor? What do you know about any worker node? What is the difference between a cluster manager and worker node? If they ask like that, you need to able to answer them. Okay. So this is what it is. And we have also seen RDD operations. In transformations, you have two types. One is narrow transformations and one is wide transformations. Here, the shuffling is not required. For mapping, shuffling is not required. For joining or repartitioning or intersecting the things, we need a shuffling. In actions, whatever the action you have. See, the list of actions are very small, right? The count, collect, take, count by value, top, reduce, fold, aggregate, and for each. So uh, we have discussed each and every point in practical, how we can create RDD, and upon RDD, how the actions are performed, how the transformations are performed. We have seen each and everything, right? So try to understand that particular thing. Okay. If you don't write collect off for any um, syntax you have written, it will not execute, right? So remember that particular thing. And you need to understand the difference between the repartition and coalesce. So this is also one of the most important thing from the point interview perspective. Okay. So you need to do that one. You need to understand that particular thing. And you have joins. See, in RDD also you have joins, and data frames also you have joins. But in data frames, we have two more joins, which is left anti-join and left semi-join, which you have learned in this, right? So um, make them all in a notepad, like create a important points notepad or something and write it each and everything. What I'm saying, like from interview perspective, what are all important, just have a note. Okay. Even though if you are not taking it, but listen. Okay. Because next month you are having the campus interviews on this, right? So try to concentrate. Then it is easy. It is not difficult. Till now, whatever we have discussed, do you feel something really hard in this particular course? No, right? No. See, uh, tell me from your end. if there is anything that is really hard you feel, I will try to explain it more simpler way. Any topic. Okay, if you say don't say anything, I'll consider this as no only. But I'm saying again and again, take a list of topics which really feels you hard, means to understand it or to execute it from your end, you feel like it is not executing and you couldn't understand the thing. List them and ask me. I will repeat the things. Okay. If you don't ask me, I will never know, right? Which one is very hard to you, correct? So data frames we have discussed. After RDD, we have discussed about data frames, right? In data inside the data frames, we have discussed about column functions, row functions, joins, and optimization of joins is the important thing. One of the most important thing. And inside this one, we have seen this particular one, which is broadcasting. Broadcasting in our practical example. So this one, and in RDD, gloom function. I forgot to mention gloom function is also important because it will show you how the data has been partitioned inside. See, every time you write RDD dot some RDD dot collect offer, then what it will do, you never know how the data has been partitioned, right? But when you write rdd.gloom of dot collect of, then it will show you the partitioned, how many partitions the data we have, and in each partition, what data we have, we all get to know. So that is the thing. See, in Spark also, RDD is at very ground level. When you are dealing with huge data, you may not be able to use the collector function because it will collect each and everything whatever we have. Okay, above RDD, you have this particular one which is data frames. Why when I say above RDD means see, RDDs are created on Spark context. If you remember or not, we will initialize the Spark session and then we will create a Spark context out of Spark. And using the Spark context, we are creating RDD and all. But in data frames, directly we are using the Spark after initializing the Spark session. If you initialize the Spark session once, it is more than enough to run all your commands. Okay, no need to run for every notebook and for every session. It is not the case. Okay, but whatever the built-in functions we have in data frames. See, in data frames we have discussed about many more Spark dot SQL dot functions. Inside functions we have many. So remember Spark dot SQL dot window. Inside window we have many. So all those whatever you are uh, taking, um, when you write any function for data frame, you need to first import it and then only you can use it, right? That is for each and every notebook. Whenever it is starting, it is required to import. Okay, but for Spark context, initializing the Spark session is not like that. If you initialize once, it is not required to initialize it for each and every notebook. Okay, so that is what I want to tell you clearly. Okay, so we have discussed about window functions, aggregate functions, and date and time functions for our data frames, right? And similarly, we have seen all of them for Spark SQL also, right? And after the Spark SQL, we have discussed few things like we have discussed. So once the Spark SQL has been completed, what are all the things we have discussed? We have discussed the things with respect to the Databricks workspace. Means how you can integrate the Databricks workspace with other tools. Means how to get the data, how to load the data, how to manage the data you have learned till now, right? means you have learned all of them, right? So remember one thing. Inside the Databricks workspace, you have the dbutils command. So that particular module, dbutils module, will have all the things which are required. Okay. So in yesterday's session, what are all the things we have discussed is inside the dbutils, we have all these, right? So out of all this, we have discussed about data, FS, and notebook. Secrets also we have discussed yesterday, and visuals also we have discussed yesterday. Correct? So, see, we have not only discussed about the Databricks workspace, but we have also discussed how to get the data, how to get the data from external resources, and how you can keep it in a secured way. Means taking the data in a secured way such that it will not have any sensitive information inside your notebooks. Okay, that is also what we have discussed yesterday. So apart from Databricks, you have already known, you have already get to know about the two other tools, that is Azure Storage Account and other one is Azure Key Vault. Correct? So key vault is having the symbol of key inside a ring, and storage account will be like a, see, a folder. Inside the folder, you are having some cards kind of thing. So it is how it looks like. Okay, storage account. So storage account will be having all the data, and this data you are utilizing inside the Databricks by mounting the data. Correct? Mounting the data. Mounting the data is a bridge for taking the data from storage account and mounting it. Means uh, it is just creating a references to the storage account, but it is not actually having it. Okay, understand the difference. So that is how we have done. We have not only seen this particular thing, like how to append the things, but also we have seen how you can securely mount the things and utilize the um, files. Correct? We have seen all of them. Now, apart from all these, what are all we have discussed in yesterday's session? So, loading the data to Hive Metastore table. Hive Metastore is nothing but the thing which you have in catalog. So, see, database tables. So, all the databases, when you work on Microsoft SQL Server, means uh, firstly, you need to have a server. Okay, and then you can create a database inside the servers, and inside the databases you will be having the tables. So three things: one is a server, database, and then tables. So this is a hierarchy. First you need to create a server, and inside the server you can create n number of databases, and each and every database contains n number of what tables. Okay, so similar to that hierarchy, what we have seen to in our Databricks, the server is nothing but Hive Metastore. So Hive Metastore is nothing but you no need to worry on creating that particular thing. It is already there. Hive is already there, and it will have one default database. Okay. And what are all databases you are required? You can do it on your own. I mean, create it on your own. Okay, we have created that particular databases, and we have created tables. And also DBFS is a Databricks file system. So inside the DBFS, we have taken the data from multiple data formats: CSV, TSV, JSON, Parquet, TSV, and text file also we have taken, right? So we have seen all the things. And what we have seen, taking the data from that particular format. See, tables are different from CSV, text, JSON, and all, right? So how you can convert all these CSV files or TSV files or Parquet files, whatever we have, how you can convert them also we have seen. Correct? So one particular, we have discussed about two methods yesterday. So we have discussed about the two methods, how you can load the data, like how you can load the data from CSV table or packet file. One is creating a temp view and then loading the data, creating a temp view out of this particular CSV or JSON or whatever it is. And then what we have done, we have created a view and for creating a table out of that one, what we have done, we have manually created a table with the same schema and we have loaded the table information like this, correct? So this is one traditional method which we have discussed yesterday. So apart from that one, we have also discussed about how you can load directly without having any table, without creating any table, without displaying any, I mean, without having any schema, how you can create also we have seen, right? So where is the second method? Df dot write dot mode of. We have seen that, huh? So this is the one. Here we have seen with respect to packet file. So df dot write dot mode of. So write is the function which is used to write the data, and mode. See, we have how many modes we have seen yesterday? Uh, Append mode, overwrite, ignore. So these are the few things which we have discussed yesterday, correct? So we have discussed that one particular thing. And today we are going to discuss about how to create an external table. Okay. So see, whenever you write a thing here inside the, okay. See, whenever you write something here, save as table. So this is the function this is the function which helps us to save the particular data frame, which helps us to convert the data frame into a table. Okay. So this is the function save as table. So here, whatever you are writing, that will be the table name. Okay. If you want, you can write the database name also. Database name dot table name. You can utilize that in that way also. Because here, if you do save as table, then what it will do, it may go into the mm, default database also. So that is the reason why I'm suggesting you to use the database name also. Okay. I'm just executing this command. Okay. And what else we have seen yesterday? Yeah. So we have discussed loading the data from local. Local means from your own local directory, C drive, D drive. We'll be having the data, right? From there, how you can load the data. See, that requires a CLI, Databricks CLI, installing the Databricks CLI and working on that. So that is very least used, I could say. So just think in such a way that you can load the data from local also. Okay. And one more thing is loading the data from external table. So see, this particular one we'll be discussing now. And the other one is loading the data from HDFS. So mostly we will not be using the 1 and 3, but yeah, 2 will be used very frequently. Okay. I haven't shared you this particular one, right? I will share you. Okay, today because yesterday I have faced many issues with authentication issue and all. Okay, so today I will share you all of them. Yesterday's notebook and today's notebook also. Okay. So see, today I'll be using the JSON file for my reference, and then I will go ahead creating a external table. Okay. So firstly, we find it. Okay. Why there is no Parquet files I could see? This is the one, right? Parquet file. Okay, JSON file. I'll take it now. I'm utilizing the JSON one. Okay. Spark dot read dot JSON of. So let me give the path here. Display of utils dot fs dot ls. Fs means file system. Ls means list. So inside the file system, you are asking to list what are all there inside this particular root directory. Okay. So we are going to use the Databricks data sets. Okay. So out of this one, IoT is what I'm going to use, right? This is the issue from not from my end, okay, but Databricks community version is having some issue. I have raised a ticket for the same, but I haven't get any resolution yet. Actually, this Databricks community version is lifetime free for all of us. To learn the things, they have made it free for all of us. But see, till now I haven't faced any issue. But from last 2 days, yes, this is being very trouble. Even though you use this particular Azure Databricks workspace, it is only credit based. Once the credit has been completed, you will not be able to uh, create the cluster and you will not be able to utilize any of your things. Okay. So you need to pay for it once it is done. So rather than that, this is a very easy thing. That's why I have chosen and info schema equals to true and header. So it is not allowing me to write at least a single command, which is not really good for session. Like the session should go in a flow, but this is always pulling back. Okay, spark dot dot we have given. That's why this thing invalid syntax. Let me remove this particular one. Okay, let's not go into that one. Let me do the same thing here. Even my credit has been completed. Let's not think of this community version again. This is really expensive, but we don't have any option now. Let me see if the computer is still active or not. Okay. So here you can see the Databricks workspace, SQL, data engineering, machine learning. So these are the three different scopes which we have inside our Azure Databricks. Okay. But in our community edition, it is not giving all of them, but few it has given, like machine learning only. But rest all it has not given us. Okay. So this is also running slow. Okay. So I have created one cluster. Okay. Let me go to the workspace and create a notebook for today's session. So this is also integrated with AI assistant. Okay. So whatever the error you might be facing, it will definitely try to resolve it, giving the steps. There is no need of asking any ChatGPT or Google. Okay. Now it's time for Databricks assistant. Okay, so let me copy paste it and then we shall not go back to community version. Okay. Let me not waste our time. If underscore JSON is equals to Spark dot read dot JSON. So here we need to give the path, right? So details dot fs dot ls. I have given you assignment on this particular file only. Okay, so you utilizing this particular one only. Okay, JSON will not have this particular things. That's what it is trying to say. Let me create. So what we are going to discuss today? We are going to discuss about external tables, right? So external tables. Okay. So see, here we have the data, correct? And from that particular position point, we need to take the data and create a table. So yesterday, what we have seen, df dot write dot mode of override and save as table. So that is one of the method which we have learned yesterday. And today, we are using this particular thing. See, same can be applied for this also, but we are using it in a different way today. Okay, let me go to the SQL one and create create table. See how you can create is external table. Create external table, and I will create a table for ID underscore external table. Okay, external table I'm creating. Okay, so I can create it like create the external table name, and using CSV. Okay, I have one CSV file for ID, so I'm utilizing the same thing. And now I need to give the location one. So the location is I need to upload it in a catalog first, correct? So browse DBFS inside the file store. Let me upload it inside data folder. Okay, data slash. Inside data, I have created one id.csv. Okay, let me utilize the same thing. Remove this dbfs from the beginning. Okay, see what you're doing. You are creating a external table, and you are not specifying the schema also. Directly you are saying using the CSV and this location, you are going to create it. Okay, let's see what it will do. Okay, for this one, I think DBFS is required. That's what it is saying. Let's see. This is saying this is not a valid parameter, but missing cloud file system scheme. Okay, but inside the catalog, default samples. Okay. So inside the browse DBFS also, we have only this particular one, right? File store, data, and ID. Hmm. Okay, it has been loaded. Let me do one thing. Whatever I have created here, let me do the same thing here. Let's get the PDFs file location. Okay, inside data, inside input, we have id.csv. Let me copy the path and show you from here. Okay, see, this has created a external table. Okay, let's see where it has been stored. See, in the default only, it has been stored as ID external table, right? So this is how you can create an external table. Yesterday, we have discussed two other methods also along with the external table method. Okay, I will share you both the notebooks so that you can understand all the methods of loading the data to the tables in the inside the database. Okay. So this is how you can do it. See, now I will execute it and I will show you what is the data inside that one. Select star from ID underscore external underscore table, right? This is what we have taken. Let's see the data. It will see. This is the one. See, it has taken C not as a column name. ID 1, 2, 3, 4. ID also it has considered as one of the row column. Okay. So for this one, what we can do is see after the location what you have given, you can specify the options like header equals to true and all. Okay. Let me copy paste the same thing and I will show you the difference. Okay. This time external table one I will create, okay? And after the location options space. Now that we are utilizing this one, header equal to true. Okay. So let's see what it will. It has created, right? Let me copy paste and show you. External table one. This time the header will be ID. See, ID has been created as one of the column name and the data inside it. Okay, so this is how you can create with respect to the external table. So whenever you are creating the external table, you can use the database also. Use database and you can create it. If you don't use any database, it will automatically take the default default database and then there it will be created. Okay, clear everyone? Loading the data using the external table. So we have seen that one. So we have seen all the methods how you can create and load the data, create the tables and loading the data. So now we have seen all of them. Now we are going to see the partitioning of the data. Okay. So in partitioning of the data, whatever we have seen yesterday regarding the Parquet file partition. So inside the Parquet file, when you are writing into a Parquet file format, what we have seen, you can create partitions based on the syntax, correct? So where is that one? Insert into table. Yes, we have seen. And is that day before yesterday we have seen the Parquet file loading based on data frame partitions like true or false or something like that. Anyways, I'll show you from catalog, okay, from DBFS. So whenever you create a Parquet file one, so see here inside the Parquet, employee Parquet. So this is having two partitions. One is for female employees and another one is for male employees. Here you have created a Parquet file with respect to partitioning on gender. That's why you got two. So not only one particular column you can use for partition, you can use how many columns you want, you can use for partitions. What it will do inside each and every partition, it will again create one further partitions, and that is how the data will reside. So that is one particular thing which we have discussed earlier. Now, see, you have discussed that with respect to Parquet file, but now we are going to discuss it with respect to relational database. Okay, how you can create partitions and how you can load the data with respect to any partitions and all, we will be seeing it. Okay, so partitioning of the data. Firstly, we have already read the JSON file, right? So inside the JSON file, we have df underscore JSON dot show of 10. Okay, I will take only 10 records. So we have all this data. Okay, now that to create a partition table, we'll do one thing. I will use the first method, df underscore JSON dot write off. I'm directly creating like this. Write dot mode off. Mode should be overwrite. Mode should be overwrite. Dot save as table. Save as table. And the table name is IoT. Okay. So I'm creating this particular table using this. Now that I have created a IoT table, it will have all the information of this particular things in IoT. Okay, this is the general way how you can create a table. This is one of the method. Apart from external table one, you can do this particular one also. See, this is the first you need to take all the data into a data frame, and out of that data frame, you are creating a table. But in external table, what you're doing, creating first an external table, and then you are using which format, like which format you are utilizing for the file location. I mean, from the file location, the file format you are taking first, correct? So that one we have seen. Now, what I'm doing is, let me show you how you can create a partition table. Okay, create table, IoT, partition. Okay, IoT partition table I'm going to create. But see, I'm not going to take all the columns. I will be taking only few of the columns here. Okay, what are all those columns I'm going to take is battery and device ID, device name, battery level, device ID, device name, and IP. Okay, just for our example purpose, I'm taking it. Battery level is integer 1. So integer. IP is a string 1. Okay. Scale is again a string 1. And string and this particular LCD, right? LCD is also a string. Okay. And firstly, we will be having the country code. Country code column name is CCA2. Country code. Okay, we have taken country code, uh, battery, IP, scale, and LCD. We have taken only these particular fields. Okay, now you need to give like partition, partitioned by what country. See, remember one thing. We have taken this country code. This country code is different from country. Okay, you have two columns here. If you see this particular one, this US is a country code. United States is a country name. Okay, so that is how it differs. JP is a country code. Japan is a country name. Okay, so that is what you could see. CCA3, I'll take that particular one. Okay. So how many columns we have taken? Country code, battery, IP, scale, and LCD. 1, 2, 3, 4, 5. Okay. And sixth one is a country one. I'm saying partition by country means this is also one of the column inside this one. Okay. Inside this partitioning, we have two methods. One is explicitly mentioning which partition you want to insert. I mean, into which partition you want to insert and all. Second one is dynamic one. I will show you what is the difference between both of them and how you can get the things and all. Okay. This is seriously not working at all. Okay. So I'm going to create this particular one. Let me click on Shift Enter and see what it will do. Okay. Okay. First one is a string one. See, it has created a table. Okay. I'm just writing select star from IoT partition table. Okay. Let me show you. It has no data as of now. Query return, no results because we have only created, but we have not inserted. So the method one, how you can insert is explicitly mentioning. Explicit method. Okay, how you can insert it. Insert into table IoT partition IoT underscore partition underscore table. Okay. IoT partition table and select. How you can do select. What are all the things we have discussed here? First one is country code, right? CCA3. Okay, what are all the data you want? You need to give it here. Okay, battery level, IP and scale. IP, comma, scale, comma, LCD. So I have taken only these columns for now from IoT. Okay, where now I'm mentioning where CN is equal to India. Okay, I will give as upper of. Okay, so see, understand the syntax. Okay, see, I'm inserting the data only, but in a different way. What I'm doing first, I'm just inserting into a table and selecting the data from already table which I have. This is one method which we are explicitly mentioning on the means only I'm providing India data only. This is explicitly mentioning the things, but in dynamic way, you will not be able to insert the data without uh, you will be able to insert the data without providing any parameters like it will automatically consider the data in partitions way. Okay, so we'll see how we can do that particular thing. Okay. And here also partition table. Here also we need to give partition by partition of country. Why we are giving this one? This is because, see, I'm giving as India. Why? Because, see, this is a partition table, and here we are partitioning it with respect to country. So, first you need to mention, right, into which partition you are inserting this particular data. That's why I have given as insert into table, and partition is India, and this is the data you need to insert. Let me click on Shift Enter, and we'll see. Okay, upper of CN, right? So not sure what is the issue. It is not logging me in. In the meantime, you can do one thing. You can open the assignment document which I have shared you and check all the questions. If you have any doubts with respect to questions, understanding the questions, let me know. I will explain you. Okay. Okay. Pause for a moment. This has been restored. Okay. See, Now that I have inserted the data into India partition, we'll see what data we will be having. So with respect to India, you have these many number of rows, number of affected rows and number of inserted rows. So it is giving the count of rows which has been inserted. Okay. So let me show you. Select star from IoT partition table. Okay. See here the country code it has given battery level, IP address, scale, LCD, and country. Right? See, while creating the table, what I have done, I have taken this particular things and partitioned by this particular thing. But this is not included here. It does, but when you select the particular data, you will always have the partition column also. Means how many columns you have originally? 1, 2, 3, 4, 5, and 6. 6 columns you will always able to see. Be in partition, you can have multiple columns. Okay, not only a single column. Based on your requirement, you can create multiple partitions. Okay, so this is how you can check. Okay, but for now, I have created only Indiana. This is the explicit one. So I will also show you one more method, dynamic method. Okay, what this will do, we'll see. No, not create. Insert into table IoT underscore partitioned. Okay, and it is partitioned by partition of country equal to see before we have given partitioned by country India or USA, something like that we have given and we have taken, but now I'm just saying it is partitioned by country, that's all, but I'm not going to give any value. Okay, this is the dynamic method because we will just say partition by country, but we will not give into which partition you are inserting. Okay, select, let me copy paste it from IoT. See, even if I don't write where condition or if I write where condition excluding India, it will be the same thing. That's why to have the data for India again? Let me remove it. Okay. CN upper of CN, not in India. Okay. Let me uh, show you what it will do. See, what it has showed to us cannot write to this partition table, not enough data columns. See here, how many columns we have given? 1, 2, 3, 4, and 5. Where is the country column? It is not there, right? That's why it is showing you error. But before you have not included it while writing explicitly. But while writing, because there you mentioned what partition it is. So automatically it will consider the country as India only because you have explicitly mentioned it. But now here you didn't. That's why you need to give the country name also while selecting the data. Okay, clear everyone? Because this is giving some disturbance to all of us. We are not able to take the flow of the session, right? But what can I do? There is a issue with the Databricks community version, and inside the Databricks, Azure Databricks, it is expensive, and most of the things will have access, very less access permissions and all. Okay, that's why I'm continuing here only. Let me write CN also. CN is a one which is equal to country name. Okay, so it will take all the data now. Okay, we'll see what it will give us. Since it is very huge data we are dealing with, that's why it is taking much time to process the data. Means taking the data from one table and inserting it into another table. Okay. Why? Because see, here these many records it have inserted. So that is the reason. 1,96,297 records. Okay. So this is how you can do it using dynamic method without specifying the partition name. And if you are doing it explicitly, mentioning the partition name and into which partition you want to enter, this is the syntax. Okay, clear everyone? So once you have inserted all this data, let me show you if all the data has been inserted or not. Okay, select this thing, count of distinct. Count of distinct of country. From IoT partition table. See, 208 countries we have. Okay. So let me show you now how many partitions we have. We can also see that one. So for that one, the syntax is show partitions. IoT partition table. So here you could see 209, including the country, I believe. So that's why it is showing 209. No, without including that only, it has showed all the things. But let me identify where is India. Uh, okay, so it has total 209. But here, when we count it, it has given only 208. How come one will be missed with the same particular partition table? Okay, the null value also it has considered. Means the thing is, it is also considering null as one partition. That's why you have 209. But originally, how many countries we are dealing? We are dealing only 208. Okay, I hope it is clear to everyone now. You can see how many partitions the data has been defined in such a way. Show partitions and the table name. Okay. So today you have seen how to create a partition table. how to load the data into a partition table. And inside that particular one, you have seen two methods of inserting the data into the partition table. One is dynamic method and other is explicit method. Correct? You have seen all of them. Now that we have seen these two, we have also seen how many partitions this table is consisting. We have seen. So let me go to catalog and show you how it originally looks. Okay. So partition table, when you click on this particular one, I'm not creating any database. I'm just using the default database today. Okay. See here, default.iot partition table inside this one. So let me refresh it. It will show you uh, differently from a regular table. Okay. It is taking time to load. Okay. See. Schema, country code, battery, IP, scale, LCD, country. And also it is saying partition information, column name, country. And the data type and comment also it has taken. Okay. And the sample data which we have inserted also, it is consisting. So this is how you could actually see the data inside the database without querying anything also you could see from catalog. Okay. So that is possible. But generally this IoT I have created now, this is a regular table. This is not a partition table. But see here you will not be having any partition information. But this IoT partition table will always have the partition information. Okay. Similarly, you have seen this two methods, dynamic and explicit. You can always alter the table and add the partitions, and you can also alter the table and drop the partitions. It is up to you. Okay, we shall see that also in practical. This is taking time to load, but you can check it from your end also how this has been created. Okay. Hmm. See, this is the normal table which you could see. You couldn't see any partition information, something like that, right? So this is the regular table. So size is 7.75 MB and number of files is 8. So what number of files is 8? Not sure. But see, partition columns is not there. But the one which we have created will have partition column and column name. Okay, so that is how it is. So this is the sample data. I'm going back to the notebook now in Azure trainings, 13th session. Okay, so you can also add a partition and drop a partition, right? So let me drop one partition, how you could do, and also I will add the same partition. Okay, how you usually add a column or drop a column in your regular SQL, it will be the same thing. Alter table, alter table IoT partition table. Okay, drop partition. See, drop partition off. So country is equal to, let me give as India. Okay, let me drop this particular partition now. Operation not allowed. Alter table partition is not supported for, okay. See, this is not supporting here, but in Azure Databricks it will definitely work. Okay. Let me do it for add also and see what it will throw me. Let it be. If I don't drop something, I cannot add also, right? But when you add, it will be the same thing. Alter table, table name, add partition country equals to India. So you can add it in the similar way. You dropped it. Okay. Let me delete this command and go ahead. Okay. So till now, whatever we have discussed is loading the data from external tables, and inside the external tables, I mean, taking the data from external tables is of two ways. One is spark dot write dot mode of overwrite and saving the table directly. That is using Python. See, that particular thing is in Python. How you can convert the particular file to what table. And when it comes to SQL, you are writing as create external table, and then you are writing the create external table using CSV and location you are specifying. So that is the difference between converting the data using Python and converting the data. See, this is the SQL one. Okay, this is how you can create using SQL, Spark SQL. Convert the data of any CSV file to a table. And when it comes to Python, I have showed you. This is with respect to Python. Here, what you have done, df.write.mode of override.save table of IoT. Okay, so this is in Python and that is in SQL. So we have learned these two. So till now we have discussed all these, right? So I will give you some brief information about the data lake and delta lake and all. Okay. Half of my time has been taken by this particular authentication method only from past 2 days. Okay, let's not go to the practical session now. I will show you, I mean, I will explain you a few things with respect to this one. Okay. So inside the Spark SQL, we have seen two things: loading the data from external table and also inserting the data into a external table. So we have two things now: load and insert. What is the difference between load and insert? We shall see today. Okay, data movement. It will move or copy the files as they are. Process and inserts the data using SQL queries. So this is with respect to uh, moving, both are same. Loading the data using file and converting it into a table is also the same thing, and creating a table and inserting it the data is also the same thing, but little bit of things are differed between load and insert. Okay, data transformation, no transformation is required here, but allows a full SQL based data transformation in when you use the insert. Okay, file formats which it will support is CSV and text. Here it will, you can, when you are inserting into the table, you can use reverse file formats, Parquet, ORC, Avro, etc. Okay, managed versus external, typically used for managed tables. Managed tables means which we have created, like how I can tell you means external table is different from managed table, and external table, when you say, when you create, syntax is create external table, but when you say normal table, managed table means you will not, you will be having a regular syntax. So that is the difference between managed and external. Okay, and apart from this one, you also need to know, like, see, whatever you are referring inside the Databricks now, inside the Databricks, everything you will be saying as delta table, correct? So delta table, all or what resides inside this particular Hive Metastore or inside the DBFS, whatever the tables are there, all those are delta tables we will refer. Delta tables means with respect to Databricks, they are delta tables. But in general, whatever the CSV file it is, whatever the Parquet file it is, when it is loaded inside the Databricks, that is a delta table. Okay. So now that you are clear with the delta tables, I will tell you one more thing. So basically, uh, Microsoft previously used to have a data lake. Okay, we used to have a data lake. I will show you that also. If I'm able to show it, I will do it. Wait. Actually, it might have deprecated now, but let me see if it is there or not. Data lake. Okay. So it has been deprecated. Okay. Data lake Gen 1. See here. Storage account. Storage account, you could see data space lake, data lake Gen 2. Okay. Means all the things what we are discussing, data lake and delta lake, all these things we will be discussing it further. But for now, imagine like the storage account previously used to have only the blob storage and blob storage means keeping the diverse file formats and all. We will be uploading it and taking it. It used to be like that. But later, upon increasing its what previously, it used to take only all format files, that's all. But what it has done later means it has integrated with data lake. Then what it has happened means data lake is one portal, actually. Data lake is one portal managed by the Microsoft. It is not integrated with Azure Cloud. It is a separate one. But then what it has done, portal one is a data lake Gen 1. It has migrated all the data from that particular data lake Gen 1 to Gen 2. And it has kept Gen 2 inside the storage accounts. Whenever you create a storage account, it will always have that properties of data lakes and also data lake Gen 2, which we are discussing. Okay, so there is no need to separately create a data lake Gen 2 or something like that. Okay, so this is the one thing I want to show you. And see here, if you see Azure database for Microsoft SQL servers, and this is SQL databases. So see, you can create a database and you can create a what tables inside this also. Means whatever you have learned in your college, that particular thing you might have logged into some Oracle software or something, and you have created database and tables. You can practice the same thing inside the cloud using this particular service. Wait, I'll show you that particular one. SQL Server. Hmm. See, Azure SQL. You can use this particular service. Okay. When you create this particular one, it will create this is a server actually. Inside this one, you can create your database, you can create your tables and all, which you can manually, which you are doing manually now in Oracle on premises. That one you can do it on cloud using this particular one. Okay. Not only for that one. See, you have almost all the services what are all required is on cloud. Okay. See, whenever you work on Java full stack, what are all required? Means to work on Java full stack, firstly, you need to know the HTML, CSS for the front end, and the back end it will be DB. And in order to integrate these two, you need a servers, API also you need to know, and one programming language which is Java majorly. We need to know, right? So all that particular application can be created using app services. What it will do means it will give you the storage, everything. Only thing is you need to code and deploy it. It will automatically create an application. So this is the one best tool you can use when you want to create any applications. Okay. So if you explore this particular one, you have a number of tools inside this one. And one more thing is see, data factories. See, here it has the data lake storage gen 1. See, no data lake storage gen 1 to display. But see, this is deprecated now. You couldn't create something now here. But the, this is the first version where you always upload the data and get the data, retrieve the data. Now you got this particular storage account, but before storage account, you used to have this particular one. Okay, and going further, na, you will be able to um, know about the Unity catalog inside the Databricks. So, few topics which we are going in which we are going to discuss in future is Unity catalog, most important topic, and Delta Lake, lake house structure, and how it has been created. And I will also explain you Databricks. Databricks workspace has been divided into two parts. Means one which is managed by Azure is different, and one which is managed by us is different. So those two parts I will clearly explain you on Monday. Okay. If I start now, I couldn't complete it. That's why I will explain you that particular things on Monday. Okay. Hopefully, before Monday's session, this issue could resolve, so that we will be having our sessions normally how we used to do. Okay. Even to give you notebooks, session 12 and session 13, I need to log into this one at least 10 to 20 times. This is really not allowing me to work continuously. Okay. So, yeah, that is all for today's session. We will meet you again on Monday, and we shall continue. Okay. I have given you the questions, right, inside with our document. Please go through that. And if you have any questions, let me know. I will wait for 2 minutes. Okay. Please go through all the questions and let me know in the meantime. If you have any doubts with respect to question understanding. Okay. Don't learn anything for the sake of others. Means, see, when you really want to know something, you should be that enthusiastic. But I'm really good to see people at least discount from your college. And definitely, by the end of this course, I will provide all the materials to the people who are till the end of my sessions, like who has taken all the sessions of mine. For those people only, I will provide the materials. And if required, I will do something from my end. Okay. You can check and let me know. We are left with 1 more minute. I will stay, and if you have any doubts, I will try to solve them. Okay, no one are unmuting and telling me. So I hope you don't have any questions. Okay, then we shall meet on Monday again. Please complete the assignment. Thank you all. Good night.